In this video, I'll talk about data structures and algorithms. We will talk about primitive and non-primitive data structures, more specifically, and dig deeper in strings and arrays. Data structures can be divided into two categories: primitive data structures and non-primitive data structures. The former is the simplest form of representing data, and the latter is more for advanced tasks and is more complex. The primitive data structures are the most basic data structures. They are building blocks for data manipulation and contain pure, simple values of data. There are four primitive variable types in Python, including integer, float, string, and boolean. Integers are whole numbers from negative infinitive to positive infinitive. In Python, float models real numbers as approximations, and it uses single precision floating point standard with 32 bits, in which 23 bits are used for the fraction, 8 bits are used for the exponent, and 1 bit is used for the sign. Double precision floating point standard can be used as well via the NumPy library. Strings are sequences of characters, and they are immutable, meaning once you create a string, the string cannot be mutable or changed or modified. We will see more about it later. And the most simple is boolean. The values of a boolean variable can be true or false. The boolean structure can be implemented as bits, but often as bytes. Now we talked about strings. A string can be viewed as a special type of array. Once created, a string cannot be mutable, meaning you cannot change anything to an existing string. Typical string operators and functions include string creation. So let's say we create a string with the value welcome to the city. So here the variable s is assigned to the string welcome to the city. So it has the memory address of the string in the memory. If we want to access to an element, which is actually a character within the string, we give it the index of the character. So let's say we want to access to the fourth character in the string, then we say s, and the index would be given as 3. And this is because string is 0 index based with indexes starting from 0. If you want to get the length of a string, then we use the length function. If we want to concatenate two strings, we use the plus, like s plus t. We need to put some carefulness here. S plus t would mean we create a new string, and the value of the new string is the concatenation of the value in s and the value in t. String slicing, meaning we want to take a slice of the string, then we give it the index of the first letter. Also careful that the notation s 2 to 4 would mean we take the letter or the characters at the index 2 and 3, but not 4. If you want to check if a string is in another string, then you use the in operator. So s in t would say true or false, depending if s is a substring in t or not. If you want to remove space at both ends of a string, then you use the strip method. If you want to convert a string to lowercase or uppercase, then we use the method to lowercase or to uppercase. If you want to create a string with repeated substrings, for example, 3 times a substring 01 would give a string that is composed of 0, 1, 3 times. If you want to check if a string starts with a prefix, we use a starts with method to check if a letter or even a substring is the prefix of the given string. Similarly, we have another method called ends with, which is to check if a string ends with a given suffix. There are two other methods that are very helpful in converting between strings and arrays. If we want to split a string into an array, we use a split method. So for example, welcome to the jungle, that is a string, and we apply we call the method split. Then it would return an array of which each element is a word. Split can take an argument. For example, if we want to split based on comma, then we would put the comma as the argument to split. Also, if we have, let's say, a paragraph with multiple sentences, and you would like to split to get an array of multiple sentences, then we would put the period in as an argument to the split method. Now looking at the other way around, let's say if we have an array, then you can join the array elements into a string. So if we write the string of a comma and then the join method and give it a tuple or an array, this would give us a string welcome to the jungle, but with commas in between the words. And if we want to have a space between the words, then we would, instead of the comma, then we use a space right here in order to join the words together. And as said before, strings are immutable, so once created, you cannot change any character. Regarding string comparison, the double equal operator is used when you want to compare the values between the strings. However, when you need to compare if a string object is the same or different object in the memory, you use the is operator. Let's look at an example. Let's say we create a string with the value University of Connecticut and we assign the variable uname to it. And then later we assign another variable name to uname. So what does it do here? Remember that when you create a string in the memory and assign a variable to it, the variable would have the memory address of the string. So when we assign name to uname, name now also has the memory address of the string University of Connecticut. Now let's say if you print uname equal to name, this compare the content or the value of the strings. This would return true, and of course it is true because both are University of Connecticut. However, if you print uname is name, this returns true also, right? Because both name and uname variables point to the same string in the memory. Now let's say if we change the first string, right? Uname now assigned to a new string, University of Connecticut. Now you may think probably this doesn't change anything because previously uname was assigned to the string University of Connecticut in the memory. And now you just run it again, right? You kind of run it again, assigning uname to the string University of Connecticut. However, actually this line of code creates another string um, University of Connecticut in the memory and assign uname to it. Now if you check uname equal name, this returns true. And of course, because the content of the two strings are still the same. However, if you print uname is name, now you get false. Uname now points to another string with the same content in the memory, while name still points to the previous string University of Connecticut in the memory at a different memory location. So here you can see you cannot change anything regarding the string that uname points to. Even if you think you change it by assigning uname to a new string, it's actually just point to the new string in the memory. But the object that holds the old content is still there, unchanged in the memory. Now let's look at another example. Let's say we create a string with content university and assign the variable uname to it. And then we concatenate the content of uname and another string of Connecticut. So what is happening here? And then we actually assign uname, the same variable to it, to the result. So what happens here is that you create a new string, which is a concatenation of the value university in uname and the string of Connecticut, and then repoint the string variable uname to the new string. So be careful with what really happens when you work with strings. Now we talked about arrays. An array is a collection of items stored at contiguous memory locations. So an array stores multiple items of the same type together, and it is easy to calculate the positions of the elements by adding an offset to the base value. So usually the memory location of the first element of the array is denoted by the name of the array. For example, when we create an array, namely A, then the variable name A points to the first element, A0, which has a content of 1. And then we add offset to the base value to access to other elements of the array. For example, A1 is offset by 1, A2 is offset by 2. Any component of an array can be inspected or updated by the index, and this is very efficient with O1 constant time. In Python, arrays are provided by the list type. How can we create an array? So there are multiple ways to create an array. In the first example, we create an array with elements such as 3, 5, 7, and 11, and assign a variable x to it. Next, let's say if you want to create an array with multiple repeated elements, then for example, right, we want to create a number of elements with a value 0. So let's say we want it to be repeated by 10 times, and we write 0, the element 0 times 10, and probably we would want to have the first element as 1. So this would return an array with the first element as 1. and 10 next elements are 0. And then we assign the variable y to it. Another example is use the range function. With the range, and then we give it to list function to create a list or an array in terms of data structures. So this way we create a list with elements starting from 0 to 9. The next example is interesting. This is called list comprehension. So in the simplest form, let's say we create a range from 0 to 10, meaning it returns values from 0 to 9. So for each element within that range, for x in that range, then you return x. So this actually simply returns a list with elements starting from from 0, and then 1, and 2, etc., right, up to 9. This can be very much flexible if you want to, let's say, instead of x, you return x squared. Or even you can return a list, let's say x and x squared together in a list. So this way you can return even x and x squared together. So you have the first element as a list with 0, 0, and the next is 1, 1, and the next is 2, 4, etc. List comprehension can allow you to go looking into more complex structure. So what if we don't have range of something? What if in here we have a list? So what if we have a list instead of range 10, right? What if we have a list something like so let's say a list of a list. Let's say you have 2, 5, 8, 9, etc. And you would like to return just the first element in each sub-array. Right? You just let's say pick out the first element. Then you can easily do that with list comprehension. So with that, you would say you return x 0, right? For x in, and if we call this let's say y, right? Then for x in y, very easy, right? For x in y, returns x 0, right? Return the first element of x. The next two function, map and filters, are very useful also. Map use is for similar purpose as list comprehension, but the syntax is a bit more complex. So here you would have to specify a function. Let's say we use a lambda function, but you can use any function in here. So with the lambda function, and the argument for the lambda function is x, you return x squared, and you would loop for each element in z to do that. So meaning for each x in z, right, returns x squared. Very much like what we can write using a list comprehension. Filter. So the syntax of filter is very much like map filter, right? You would specify a function. You can also use a lambda function if you don't want to specify the name of the function. So lambda, the argument to lambda is x. X is the argument of the lambda function. Right? Lambda without name, without function name. Return x if x is less than 5, and you go through all the elements in Z for doing that. So this also very useful. There are several ways you can create an array, right? Just like when we create a string. Right? This is very similar. And when I say that, I mean you create an array, right, in the memory, and then assign a variable to it. So in this example, you create an array with values from 0 to 99 and assign the variable x to it. Next, if you can specify exactly the values that you want to be in the array, you create it this way and assign the variable y to it. And next, if you want to have a number of elements, repeated values, say if you want to have 0 in there for multiple times, you do this. This is how you create a two-dimensional array. So a two-dimensional array basically is an array of array. Some basic operations are, for example, checking if a value is in an array. So you use the in operator. Right? You check if the value of 2 is in the array x. You say 2 in x. This would return true. If you want to append a value to an array, say use the call the append method of the array x and give it the value that you want to append to the end of the array. If you want to remove an element of the array, call the remove method and give it the element. And if you want to insert an element to an array, call the insert method and tell it where you want to insert and which value to insert. The complexity for checking a value in an array is O(n), and so are the remove and insert methods. Append has the time complexity O(1). Now we talked about shallow copy and deep copy. Let's say we create an array with content containing 1, 2, 4, 8, and 16, and we assign a variable a to it. And later we create another variable, namely w, and we assign w to a. So this means that w now has the same store the same memory address of the array. So a and w now point to the same array in the memory. If we print w, we get the same array. Now if we append, let's say we append 10, the value of 10 to the end of the array a, and we print w. Note that we print w, not a. What we get is here, the array. This is because w points to the same array as a. So when you print w, we print the content of the array. Now let's change a little bit. Let's say now The first line of code is still the same. We create an array and assign a to it, and then we slice the array a, the array which a points to more exactly. So we have we slice with we give it indexes starting from 0 to 2. So then what happens here is that an array with the content 1, 2, and 4 is created, and W then points to it. So W here then points to the newly created array. So meaning W has the memory location of this array, or more exactly the first element of the array. Okay, now we try to change the element in the first the index of 1, which is actually the second position of the array W. So we change it and give the new value of 1000. And note that we change in W. Right? We make the change in W, and then we print the content of A. So what we see would be the same thing. Then A was unchanged. So this code, you made a shallow copy. Right? You made a shallow copy by doing this. You made a shallow copy of A, right, by doing this, by doing slicing. So this is when you need to make a copy and then later on change the copy and still keep the original content. However, this only works when the content is very much like one level of depth, like this. Let's look at an example when we have the second level of depth. So A now is not a simple array, but now an array of elements, simple elements, and also of arrays. The fourth element in the array A now is a subarray containing 8 and 16. So if we try to follow the same steps previously we did, we now make a shallow copy of A. And then we print W. What we get is this. And we thought we get a separate copy from A. And we can safely make change to this without changing anything in A. So let's see about it. Now we change the element of which the index is 1 in W. And then we print A to see if A is changed. A now returns this, right? So that is good. So A was unchanged. If A was changed, then we will see this change to 1, to 1000. But A was unchanged, and we thought it is good. Okay, now next, let's change the first element of the subarray standing at the index of 3. This is not really the first element, but the index of 1. And this is the second element more exactly. And we change the value of it to 1000. We change in W. And we print A to see if A was changed or not. Now A actually returns you this. the subarray now was changed. You can see um, the second element of the subarray is now 1000. So you have a problem, right? You change W, but actually your A variable is changed also. So making a shallow copy is really not really solve your problem. In some cases, when you have deeper level of structures, then you would need to create a deep copy instead. Now, for doing that, you would need this library copy, and you import deep copy. Going through the same example again, but now you use the deep copy function to make a deep copy of A and assign W to it. And you again change store 1000 to the second element of the fourth element of the variable W. And then you print A. What you get is this. This is the original content of A, and A is unchanged. So this is good, meaning when you create a deep copy of a variable, you can safely work on the deep copy without any change, without any effect to the original variable.